Howdy, it's tubalcain once again. Welcome back to the shop and thanks for supporting my channel. If you have not watched this video, please do so, because what I'm doing now is more or less a continuation of that and just going further on it, as it is my wont to do. But if you recall, I had made these two long time ago. These are the ones I was ashamed of, and one of them I had even forgotten about, but these fit right onto an Aloris type quick change tool post, and there your indicator's always ready to go, and these are dedicated indicators. Well, I scrapped this, just saved the indicators off them, and in the last video you'll remember that I did this blue indicator holder that attaches into the Aloris, and that can be used as is. You know, it's perfectly solid and usable that way. However, I did take it one step farther and make one out of aluminum like this in the last video. The indicator, of course, goes on here. This is available on Tinkercad, as I told you, and that's mentioned in the previous video. So that aside, let me move on to the subject of this video. Well, after making this, and it was a big success, there's nothing wrong with this other than it does tie up one of your tool holders here, Aloris type tool holders, although they aren't very expensive. But if you have a budget, maybe you do not want to do this. And then Kevin Peterson contacted me out of the clear blue sky, and he's an expert at Fusion 360, so thank you, Kevin, and we have a collaboration. So he went into Fusion and made this for me, and I will show you the link that this is available on Thingiverse, and you can print it out and it'll look just like this, and it's ready to use, and it will hold this size indicator, which I've talked about in the other videos. So this is all-in-one. So you got your Dovetail here, and it's ready to go. The hole is printed right in there, and this is, of course, for people that have 3D printers. The counter bore is printed in, and even the thread is printed in and ready to go, although I had to run a tap in there just to clean it a little bit. And then I put a stud on there along with knurled nut that I made, and I'm not going to talk much about that, but let me go over to the milling, or to the lathe now, and put this on and just show you what it looks like on the lathe. Notice in the final version here, Kevin even included the AXA, and he's going to have this available in a B also if you go on to Thingiverse, if you have the B size. Now, if you have trouble fitting this on in your slicer, and I'm using Cura, you can enlarge it. You see, this one was just a little tight. So you can enlarge it just slightly and play around with that and get it to move freely. This is even a little bit snug, but it's just fine. And that's how it fits. And this is ready to use. And this is so handy for doing setup work on the lathe. And you just set it on your lathe and dedicate that indicator, and it's always ready to go. And it's so compact. That's what I like about it. You don't have to worry about a indicator holder, magnetic. On the smaller lathes, it can be bothersome, but maybe that's just me. So anyway, go to Thingiverse, print that out if you like. And again, thank you, Kevin, so much for this project, and I intend to do more with him, I hope, if he's got the time. I believe I showed this on the last video, but I'm not positive. So I had already made one of these, the prototype, if you will, out of aluminum, and you certainly could make it out of steel if you had a notion, but there really is no need. But this was the basis for what Kevin did and our collaboration. So the original design was mine, and he modified it and did what he needed to do and improved it greatly so that it looked like this. And what I'm going to do in this video, I'm finally getting down to the point here, in this video, is I'm going to make one of these pretty much to these dimensions, and there will be no blueprint, and this will be project for you if you want to. Now notice on this one, I printed out a bunch of these. And you could print it solid, but this is, I think, 20% fill. If you 3D printer people know what I'm talking about. But I printed this particular one at 100.2%, and that gave me just a little bit larger dovetail. And then I printed some other ones. Let's see, there's one that was, and that was 5 hours. That's the first one. Oh, here was the final one, I think. 100.5%, and that gave me a better fit on the tool post. So I would recommend doing that, but of course you're going to have to experiment a little bit, as we always do. So now on to the aluminum one, and thank you one more time to Kevin. And by the way, that's how the hole prints out, and you knock out that plug. That's the support. Well, naturally I don't have a piece of aluminum big enough other than this scrap. Now this was sent to me by my friend Dave from St. Louis, and I believe these came from one of the aircraft plants where cost was no object, but there's holes in all of these. But what I was going to do here, see there's holes in this also, saw it off and then get down to the basic dimension, and then I'll start giving you some dimensions. So I hadn't decided. I think what I'm going to do here is cut this to length on the bandsaw and see if the holes are going to disappear on me or if they're going to be bothersome. In other words, this is scrap. This is the overall dimensions of the blank, and how fortuitous was it that this happens to be inch and a, what did I say? Inch and a half thick. Yeah. So I milled this off square just now, and then I've laid it off. This is the blank here, so I'm going to rough cut it out on the bandsaw. This is waste up here. I'm trying to work around a hole, and I think I will, although if it does extend in there, I don't believe it does. It's not going to hurt a thing. Get your glasses on. Now this old Boyce Crane bandsaw is actually a combination wood cutting, metal cutting, so with a planetary gearbox of all things. No nonsense with belts. So I've got it sped up to that rather high speed, but it's just a regular metal cutting blade, but I think it still should be fairly fast. But it's never fun cutting off on the bandsaw. And now I'm milling it down to the layout lines, the basic blank size. The blank is down to rough measurements, as indicated before. Right here, pretty close to those dimensions. It doesn't matter too much. So now I'm going to lay out and get ready for the dovetail. Now the dovetail is the hardest part, so I'm going to do that first, so that if I should goof it up, I would start over and not have wasted my time on everything you see on the other side. So now I have covered this in other videos, so I really don't know how much detail I need to go into regarding the dovetail, but I suppose there's some out there that have never done it, and it's something I do not do myself very often. Alright, let's go through this real quickly, and I am copying verbatim from a genuine Aloris dimensions. Again, this is 3 inches, but we're really interested in the dovetail. What is the width and what is the depth? So in order to do that, the time-honored method is to take 2 dowel pins. Now it does not matter what size these are, as long as they fit in there approximately like this into the dovetail. These happen to be 1/4 inch, but as you know, hardened dowel pins are slightly oversized, not much. But then what I like to do, well, you can do it many ways. You could And it's probably going to be good enough just to take a caliper and take a measurement off of that and then write it down. But what I like to do is to take adjustable parallel, Brown and Sharp to be exact. That knurl there is interfering a little bit. And then this can be, as you know, moved in and out. Lock it if you need to, and then I'm going to mic it right across there, but of course I already have, and it's 1 inch and 10 thousandths, and I wrote it down here, and I'll write it down over on the milling machine. Don't trust those numbers to your failing memory. And then I'll take my Starrett depth micrometer, and do you remember when Jimmy DeResta sent that to me last May? So I've already measured the depth here as such, and I've written it down. It's 0.380 in this case. Yeah, and I just mentioned your failing memory. That'd make a great title for a country music song, would it not? Now here's the 30-degree dovetail cutter that I will be using, given to me by Randy Richards in the shop, and he has these for sale. So check out his website, his channel if you will. But notice that he even put a serial number on there and the insert number and my name. So thank you, Randy, and we'll see this in action here in a few minutes. I'm going to roughly lay this out on the blank, although you could do it all on the milling machine just with the DRO, but I like some base dimensions, and that will be the layout. Now I took this measurement on genuine Aloris, and it's not quite 1/350, but I'm going to call it 1/350, but I measured it on several other brands, and the measurements are just all over the place, so evidently that's not very critical at all. However, I will lay it off here as a base. My big old arm in the way. That's when I need to be left-handed. And this is 0.380 deep. Remember, that's the measurement I took with Jimmy DeResta's Starrett depth micrometer. Now I'll lay out the 30 degree, and you can use a protractor, or I like this little Starrett square. There we go. Naturally, I ran across the groove. Ready to mill, really. I'm at the Bridgeport, and that's a 3/4 carbide end mill, and I'm just roughing this out into a rectangle to approximately the layout lines. 100 thousandths deep on this pass, and I won't show all of this. There's just no need. Now you may notice that almost all of these dovetails are undercut here. Look at the green line on each side, and they're just, oh, I don't know, 10, 15 thousandths deep, and it doesn't matter at all. But the whole idea is that when I go to using the dovetail cutter, that it'll only be cutting into the dovetail itself, not cutting here in the center. So I'm going to put that undercut in there right now. I've laid it out, if you can see it, with the black lines. And 15 thousandths deep, and I didn't have a cutter wide enough to do it all in one pass, so I'll go back and forth and undercut that. Now with Randy Richards' cutter, and that's a 5/8 shank, 5/8 collet, and I've taken an initial cut, I've checked the depth, and you can see where I've taken my first light pass, and I'm going to mill it down close to the layout line on both sides, and then I'll take my first measurement with the dowel pins. I've already taken several measurements and I'm really down to size now. Clean it out real well, put the dowel pins in place, and I'll use the Mitutoyo this time instead of the adjustable parallel. Either way is okay. Wiggle it a little bit. And I'm at 1.0, that is 1.011 and a half, and remember I was shooting for the top number there, so I'm within 1.5 thousandths, and that's just good. Let me see if I can fit up the actual Aloris tool post in there, if there's room. I couldn't fit it in from the front side, so here it is on the back side. Fits in nice and locks. So now I can take it out. Worked pretty well. Well, there it is so far. Now I'm ready to start laying out the rest of it. Now remember, I'm departing here a little bit from the design of this. Remember that as Kevin did this, he reduced the amount of plastic and the printing time and all of that. And this was made out of PLA. So I'm changing some of those dimensions, which I'll talk about here in just a second. Also, I'm going to use a drilled and tapped hole here that doesn't go all the way through, although it probably would be easier to go all the way through. And it will be, the indicator will be held on with a thread rather than a cap screw that goes clear through. Now I'm not sure what I'm going to do yet about the clearance that I need for the plunger here, so I'll get back to that later on, but that was done with a ball end mill, if you recall. Now I'm laying out this semicircular notch here, and I don't think I'll have that step. I'll eliminate that, and it's not going to be quite as deep. Because in fact, if you look at these indicators, and if you make it to fit this indicator, and I showed you where to get those from Shars in the last video, you can see that the dimension here, well, first of all, the overall dimension here is 1.5 inches. Well, this material is 1.5 inches. How fortuitous was that? Or is that, for that matter? Well, then the thickness here, including that boss, which was troublesome last time, comes to, let's see, 820 thousandths. So here's those dimensions for those that are interested. I changed it to 850, so you got a little extra depth there, and it's 1 1/16 long, which is 1.062. Now let me get the dimensions on the front and the top. I'm going to give you a few dimensions here, whether it means anything to you or not, but this lug is for all intents and purposes 1/4 inch thick. And in this direction, 5/8. Did I give this yet? I'm going to call it 1.600. I'm rounding some of this off. So, if this is 5/8, half of that is 5/16, in other words, to the center of that hole. So, I've laid out this line, 5/16, transferred it over. Why? Because that's the center line of this hole. That's it down there. Eventually there'll be a hole drilled on that center line. You see, what I want to do here is swing a hole that is the radius of this, and the diameter is 1.600, so the radius is 800 thousandths, which is 25-30 seconds about, so I've set the dividers for 25-30 seconds. However, I have no place to put the point of the divider, so I've taken, I know this is ridiculous, half the thickness of the lug, which is 1/8 inch, this is 1/4 inch stock that I clamped on there and made this false center hole. I know you're thinking I lost it. I bet you're thinking that. But you see, this gives me a place to swing the Ark of the Covenant. I'm about ready to go over to the milling machine and mill this out. And do you remember in the last video I used a boring head for that, and that was kind of awkward. So I found this fly cutter and I have it set for the correct radius, so that's what I'm going to use to cut that out. But of course that's way too much to cut out with this fly cutter, so I'm going to take a roughing cutter and just mill most of this out. You know, that's all waste stock. So I'll rough that out, show you what I'm doing over there, and then I'll put this in, locate it, and feed down, clean that up to give me a fairly good finish. Doesn't really matter. Then we'll come back and I got a hole to drill here and a hole to drill and tap here. How does that sound? Yeah, a high school class would never have followed this. But you guys are full-grown men. Okay, I got a Niagara cutter here, roughing mill. Knock some of that material out there, and I'm going to be using a little kerosene on it. Did I ever tell you that Henry Ford used kerosene as a hairdressing? Probably tell you that in every video, don't I? Oh well. That's called reinforced learning, according to educators, and what we learned in college. All right. I have the fly cutter set for 1.600 and I have it positioned on the work, I hope, and I have the depth stop set and I'm ready to go, and I'm just going to feed down with the quill and see how that goes, although that's a little irregular. Rather than using the knee would be better, but let's see how this goes. I am hitting the top of the work with the back end of this, so I have a little problem there. So I'm going to have to decide what to do and reset that, although it left, I must say, a rather nice chamfer. The problem was the cutter was sticking too far out the other end, so I sawed it off with a Dremel. Back to work. And now I check it for clearance back here, which of course I should have done in the first place. And there's plenty of clearance. Let's try it again. That's more like it. I know I tentatively laid out that hole, the mounting hole, so but I'm going to transfer it. I just love transfer punches, so I'll lay the indicator in there, and I'm just going to keep it off the bottom here. I don't want it to stick out, so I'm just going to move it up a little bit so it's flush or a little bit back, and then transfer that hole. Also make sure I'm not pushed this way too far, which will keep the blue dial from rotating. I don't want any interference. I've been busy. Now I've marked where I need the clearance for the plunger, and I don't need much. So I'm going to go in there with a ball end mill, something like that. And I've already, as you can see, drilled and tapped this hole. It's a blind hole, 1/4 20, drilled 13/64, doesn't go through. So that's done, so I'll do this now, and then we got some deburring to do in another hole out here. And now a 3/8 ball end mill for relief for the plunger. There's the relief. Now I've already laid out a hole here that'll be drilled 1/4 and tapped 5/16 18. Why? Because I happen to have in stock a bunch of these long 5/16 set screws, and I've already, and for some reason they have a brass pin in the end which will neither help nor hurt anything, and I've already made up, when I did the prototype, several of these knurled nuts, 5/16 18 as a quick nut, and then this is the lock nut, also a thin pattern. I like the looks of the thin pattern. So let me go ahead off camera, I won't show that, and that's let's see, I believe 5/16 over. Looks a little far. I gotta double check that. And this way it's centered, which is 1.5 inches from the end. That hole was located wrong. It's 5/16 from the edge. You can see the old mark there was wrong, so that'll go in like that. Now what I'm going to do is break all the corners liberally. A fella could even take this to the mill with a corner mill and chamfer the corners or round over the corners or whatever you would want to do to knock those corners off, make it look good. I just take it to the belt sander or with a file on every one of the corners to break them. And here, and so on, all the way around. So here I am with Palmer's belt sander. You've seen the video on that. This is a mighty coarse belt, so I have to be careful because it'll gobble up your work. It's so powerful. That's a 3-horse motor, remember that? Safety glasses. Well, there it is, final assembly. Looking good. And there's just a little clearance here between the blue knurled part so that this will easily turn and not be locked. Let's go put it on the Logan and see what it looks like. Well, here I am at the Logan lathe. Fits right into the Aloris real nicely, and you know what, I might as well do a check here on my tail sock alignment while I'm at it. Zero it out, I'm not sure if it shows up, and I always like to back it off. Go down to the other end, and oh my gosh. It's also at 0, so I'm right on. Well, that completes this video. I hope I gave you enough dimensions to make one of these, but let's face it, again, I say this in every video, that there is no one in all of Christendom that is going to make this, and I do this strictly for entertainment value, and I hope you enjoyed the video and what I did in the shop here now. And now I got to spend about 90 minutes cleaning this place up because it looks like Sherman's March to the Sea. This is tubalcain saying so long for now, and I'll see you in my next video.